When we think about the global artificial intelligence revolution, our minds almost always go straight to software, right? We think of chatbots, generative algorithms, and clean, infinite lines of code just living somewhere up in the ether. But the reality? The AI revolution is fundamentally a heavy industrial project. It requires pouring thousands of tons of concrete, laying massive fiber optic cables across the ocean floor, and generating absolutely colossal amounts of electricity. Today, we're unpacking a company that is quietly building the physical backbone of this global AI revolution right from the ground up. They're called Nscale, and they are rapidly becoming the engine of superintelligence. But what's truly crazy is that their origin story doesn't start in some pristine Silicon Valley garage or Stanford computer science lab. Not even close. It actually starts with a really fascinating question. How exactly did a coal miner end up building the backbone of AI? I want you to picture this. A young guy is sitting hundreds of feet underground in an Australian coal mine. He's working these brutal 12-hour shifts in the pitch dark, completely covered in dust, doing some of the heaviest industrial labor imaginable. But during every single break he gets, he's pulling out business books. He's down there studying corporate finance, administration, and strategy. That young man was Josh Payne, and he knew one thing for certain: he wasn't going to stay underground forever. Fast forward to today, and Josh is the founder and CEO of Nscale, which is now one of Europe's fastest-growing AI infrastructure companies. It is just an unbelievable transition from the coal mines to the absolute cutting edge of deep tech. And honestly, nothing illustrates this journey better than a remarkably unusual encounter he had. Look, not many founders get personally handed a bottle of Johnny Walker whiskey by Jensen Huang, the legendary CEO of Nvidia. But when Nscale signed a landmark deal to supply specialized GPU clusters to Nvidia, that's exactly what happened. Payne later noted, quite humbly, he was surprised to learn I came from the coal mines. That single little anecdote completely captures the massive scale Nscale operates at today. The guy who taught himself business strategy between shifts moving Earth is now the infrastructure partner that the largest AI companies on the planet depend on. So how did that jump actually happen? To understand it, we have to look at their timeline, because it reveals an absolute masterclass in strategic maneuvering. Back in 2014, Payne founded a company called Archon Energy, and they focused on Bitcoin mining. Now, Bitcoin mining requires two very specific things to be profitable: incredibly cheap power and massive cooling capabilities. So they built out these huge data centers in places like northern Norway to capitalize on abundant renewable energy. Then, as the AI boom started to surge, Payne looked at the landscape and realized something profound. What looked to the outside world like a sudden pivot in 2024, spinning out Nscale as a dedicated AI infrastructure company, was actually a genius reallocation of resources. They already had the land, the power purchase agreements, and the high-density cooling expertise. They just shifted their massive energy footprint from mining crypto to the true gold rush of our time, AI compute. Because here is the fundamental truth of the tech industry right now. AI might be a software revolution, but it has a massive physical problem. The bottleneck for creating the next generation of artificial intelligence isn't a lack of smart engineers, and it's definitely not a lack of good ideas. The real bottleneck is the immense physical compute capacity required to train and run these frontier models. Every single time you ask a chatbot a complex question or generate a photorealistic image, you are triggering a massive physical reaction in a data center somewhere. Now, acquiring the tens of thousands of GPUs needed to process all this data is incredibly difficult on its own, but it introduces an even more terrifying physical problem. How do you power these massive superclusters without, literally melting the local energy grid? These chips run incredibly hot and they draw staggering, unprecedented amounts of electricity. Now, hold that thought for a second, because I'm going to show you exactly how Nscale completely bypassed the traditional energy grid in just a minute, and it's a fascinating engineering feat. But first, we need to understand exactly what kind of company they built to solve this in the first place. To solve this, Nscale operates in a really specific cutting-edge space. They are what the industry calls a neo-cloud. Now, traditional cloud providers, think of the big hyperscalers we all know and use, they were built to host millions of general-purpose apps, websites, and databases. Neo-clouds are a totally different beast. They're specialized cloud providers built entirely from scratch for AI and high-performance computing. They prioritize heavy industrial infrastructure over general enterprise software. They're designed for one thing and one thing only: brutal, high-density compute. Which brings us to the massive differentiator here between a traditional cloud model and Nscale's vertically integrated neo-cloud. A lot of new AI startups out there simply buy a bunch of GPUs and rent colocation space in someone else's data center. They're essentially just digital landlords. Nscale took the infinitely harder path. They don't just rent the hardware. They own the land, they own the power generation, they own the cooling systems, and they own the physical data centers themselves. They call this their ground-to-cloud stack. Let's break that down. Down at the base, you have sustainable energy generation. Moving up to those purpose-built data centers, then the massive GPU compute clusters, and finally the orchestration software sitting on top. By vertically integrating and owning every single layer of this stack, they have absolute control over their destiny. Think about it. They aren't waiting on some third-party utility company to approve a grid connection, and they definitely aren't waiting on a landlord to upgrade a cooling system. They control the deployment speed, the costs, and the ultimate efficiency of the entire operation. And because they own the whole stack, they are targeting a number that is honestly almost incomprehensible in the world of physical infrastructure. 10. They are targeting 10 gigawatts of data center capacity to power the future of superintelligence. Just to put that into perspective for a second, a single gigawatt is enough to power roughly 750,000 homes. They are building infrastructure on a scale that literally rivals small nations, all specifically designed to feed the insatiable compute demands of the world's most advanced AI labs. Okay, which brings us back to that massive power problem I teased earlier. How do you run 10 gigawatts of AI compute without destroying the grid or the environment? Well, this is exactly where their crypto mining roots gave them a massive, unfair advantage. They bypassed grid bottlenecks by using incredible, sustainable engineering. For example, their Glomford AI data center literally sits inside the Arctic Circle in Norway, and it's powered by 100% renewable hydropower. Down in Portugal, they utilize coastal seawater cooling to keep the servers from overheating. And inside the server racks themselves, they use advanced closed-loop direct liquid cooling and rear-door heat exchangers. They are literally using the natural geography and climate of the planet to keep these multi-megawatt campuses running efficiently and sustainably. And the crazy part is, they aren't just drawing up theoretical blueprints to hit these numbers. They already have around 25,000 active chips running right now, today. And they have massive pipelines of the absolute latest specialized Nvidia hardware, like those highly coveted Blackwell and Vera Rubin GPUs on the way. They have the power, they have the buildings, and they have the world's most sought-after silicon running in perfect synchronization. But right here is where the story takes a super fascinating strategic turn. Nscale had the hardware locked down, right? They mastered the concrete, the electricity, and the silicon. But they realized a crucial element was missing if they wanted to become a true powerhouse in the modern AI economy. Having the chips is great, but how do you actually make them usable and efficient for developers? I'll reveal exactly what massive software asset they acquire to solve this in just a second. Because the truth of the matter is, renting out raw GPUs by the hour is ultimately just a commodity business. Anyone with enough capital can buy a chip and rent it out to someone else. The real magic, the sticky, high-value part of the business, happens in the software layer. You absolutely need an orchestration layer that decides how a massive, complex AI training job gets split up across thousands of chips simultaneously without the whole system crashing. You need the software that turns a warehouse full of hot metal into a seamless, easy-to-use cloud experience. So what did Nscale do? They went out and acquired Nscale. And this was a massive, game-changing move. Nscale are the makers of the open-source Ray framework. If you aren't familiar with Ray, it is the underlying orchestration software used by the top frontier AI labs in the world to manage their incredibly complex workloads across vast fleets of GPUs. By bringing Nscale in-house, Nscale fundamentally transformed themselves. Overnight, they were no longer just a digital landlord renting out hardware. They became a full-stack AI cloud platform. Basically, they bought the brain to run their massive physical muscles, which is perfectly summarized by this quote from CEO Josh Payne. He said, "Most infrastructure providers just buy GPUs and rent them. We build and own every layer ourselves." By combining raw, sustainable computing capacity with the purpose-built Ray software tools for training and inference, they completely realize that ground-to-cloud vision. If you are an enterprise AI developer today, you don't have to piece together your own messy infrastructure anymore. You just plug directly into Nscale's ecosystem, and they handle everything. Literally, from the hydroelectric dam generating the power, all the way down to the code orchestration. And today, this physical footprint is literally spanning the globe. We've talked about Glomford up in Norway utilizing that 100% renewable Arctic hydro. But check out West Virginia in the US. They are building the Monarch Compute Campus there, which is actually the first ever state-certified AI microgrid in the United States. And over in Sinise, Portugal, they are leveraging the Atlantic Ocean for that coastal seawater cooling we talked about. They are strategically placing these massive infrastructure hubs exactly where the geography and the energy policy favor high-density compute. And mapping out this global footprint ties into another huge, often overlooked strategic advantage: sovereign AI. Governments and highly regulated industries are frankly terrified of having their sensitive proprietary data trained on foreign servers. They are navigating really strict regulations like GDPR in Europe and the EU AI Act. Well, Nscale is building this sovereign AI backbone for the world. Because their infrastructure is vastly distributed and entirely self-sufficient, they can offer true European sovereignty to EU companies and strict US compliance to American enterprises. They provide a secure, localized environment where government can deploy national AI infrastructure without exporting their most sensitive data across borders. When you step back and look at the whole picture, the genius of their execution playbook is just its brutal simplicity. Step 1. Secure cheap, sustainable power behind the meter. Step 2. Build dense, liquid-cooled, prefabricated data centers. Step 3. Deploy advanced GPU superclusters inside them. And Step 4. Orchestrate the entire thing with cutting-edge software. It is a massive, capital-intensive, logistical nightmare for most companies to even attempt, but it traces all the way back to that disciplined, 12-hour shift coal mine work ethic. They are out there doing the heavy physical lifting that the pure software startups simply cannot do. Which leaves us with a really fascinating question to ponder. We spend so much of our time obsessing over which company has the smartest language model or the absolute coolest generative video tool. But as AI scales up and demands practically infinite power and hardware, who really controls the future? Is it the software creators writing the code, or is it the infrastructure builders who actually own the power, the land, and the cooling systems that allow that code to exist in the first place? In a digital gold rush, Nscale isn't just selling the pickaxes. They own the land, they own the power grid, and they own the entire supply chain. And that might just make them one of the most important companies of this entire generation. Now let's talk about its market value, specifically the absolutely staggering, multi-billion-dollar numbers driving this impending US listing. We're looking at a company attempting to bridge the massive gap between what hyperscalers actually need for infrastructure and what our physical power grids can actually support. And they're leveraging that specific bottleneck into an unprecedented financial narrative. But the real question for us isn't just how they arrived at this number, it's whether their physical reality can actually cash the massive checks their valuation is writing. So let's dive right into this explainer and unpack the data, because the figures floating around ahead of this public debut are, quite frankly, historic. Right out of the gate, the target IPO valuation for this upcoming September listing is up to $25 billion. That is a massive premium being pitched by lead underwriters Goldman Sachs and JP Morgan. To really put that into perspective, back in March of 2026, they closed a Series C round that valued the company at $14.6 billion. That means they're attempting to nearly double their valuation in the public markets in just about 6 months. For investors, a markup of that magnitude in that tight of a window isn't just ambitious, it demands rock-solid, completely flawless financial justification. You don't just get to command a $25 billion market cap without proving your underlying economics are absolutely bulletproof. So how exactly do bankers pitch a premium like this to institutional investors? Well, it all comes down to this classic hockey stick growth. This valuation is firmly anchored by explosive revenue growth, jumping from $33 million for all of 2025 to clearing $100 million in just the second quarter of 2026 alone. Now, keeping in mind the first quarter of 2026 sat at about $37 million, this means their annualized run rate is suddenly pushing somewhere between $400 and $500 million. That is the exact shape of an AI infrastructure business catching a massive wave of GPU demand, and frankly, it's the exact trajectory required to sell a $25 billion premium to the street. And if you track how they've been accumulating capital, you'll see a company moving with incredible velocity, nearly doubling its valuation in just 5 months, since pulling off the largest Series C in European history. They raised a $1.1 billion Series B in September 2025, layered on a $433 million safe note, which is essentially a fast-track investment converting to future equity, and then pulled in a historic $2 billion Series C led by Aker ASA and 8090 Industries in March 2026. The capitalization strategy here is highly aggressive and highly intentional. They're blending financial heavyweight investors like Citadel and Point72 with strategic industrial players like Dell and Nvidia. Now, the crucial point for us is understanding where all this cash is actually going. This rapid fundraising of over $3.3 billion, it's entirely necessary because they aren't just renting out servers in the cloud, they are financing heavy, physical AI infrastructure. We're talking about acquiring actual earth, pouring concrete, laying microgrids, building out highly advanced liquid cooling systems, and buying insanely expensive silicon. They are quite literally building the physical backbone of the AI economy. This is a game of extreme capital intensity, and it's a sector where you absolutely cannot bootstrap your way to the top. Which brings us to their structural strategy. Unlike traditional hyperscalers that lean heavily on public power grids, Nscale utilizes a true ground cloud of vertical integration. They own everything from the power generation microgrids and data centers right up through the GPUs and the software stack. This is what defines the modern neocloud, a provider built specifically and exclusively from the ground up for AI workloads. Where typical operators might lease wholesale data center space and face agonizing 70-year utility interconnection queues, this company's out there buying land, generating its own behind-the-meter power, and packaging it all the way up to the orchestration software. But as an investor analyzing this, your critical question has to be, does this highly capital-intensive model actually yield a structural cost advantage in a notoriously thin margin industry? GPU cloud rental gross margins are generally estimated to be just in the mid-teens once you factor in labor, skyrocketing power costs, and massive depreciation schedules. So, if you're going to spend billions building independent microgrids and modular liquid-cooled facilities all over the globe, that vertical integration absolutely has to result in significantly better unit economics. Because if it doesn't, you're really just setting capital on fire. Well, the company's answer to that margin question is just massive efficiency. They claim their vertically integrated, renewable-powered model provides huge cost savings and performance enhancements over their grid-dependent competitors. By leveraging 100% renewable Arctic hydropower in places like Glomfjord, Norway, they are essentially practicing advanced margin engineering. Lower power costs as a percentage of operating expenses, combined with a claimed 40% better resource utilization and 7.2 times faster inference using GPUs specifically tuned for AI matrix math, that creates a theoretical moat. It allows them to compete fiercely on price while still protecting their profitability. And those bold efficiency claims are exactly what they're using to pitch what is probably the most shocking number in their entire prospectus: a $51 billion contracted revenue backlog. This is the headline figure circulating ahead of the IPO, and it's the number intended to prove to Wall Street that their multi-billion-dollar capital expenditures are already completely de-risked by guaranteed future enterprise demand. It signals to the market that they aren't just building speculatively, hoping customers will show up later. They are building to fulfill existing signed orders. However, when we actually analyze this backlog, it reveals a pretty severe customer concentration risk. They are heavily reliant on just a few anchor clients, most notably Microsoft and OpenAI. For instance, their backlog includes a massive 5-year, $6.2 billion binding agreement with Microsoft to secure high-performance AI compute. Now, having Microsoft as an anchor tenant is a phenomenal validation of their technology, no doubt. But it also means a huge portion of their financial future is tied directly to the strategic decisions of just a handful of massive tech giants. Simply put, if Microsoft catches a strategic cold, Nscale risks getting pneumonia. So we have to stress test this bull case, right? We need to ask how many of these multi-year paper contracts will actually convert to hard cash before the GPUs are even switched on. You see, in this industry, a multi-year compute deal counts toward the backlog in full the very moment both sides sign the paperwork. But that can be years before a data center is actually built, the chips are installed, and workloads are actively being built. That gulf between a signed piece of paper today and actual realized revenue 3 years from now leaves the company highly exposed to shifting market dynamics. Because fulfilling this massive backlog requires totally flawless execution to scale their current 60-megawatt operational footprint to an unbelievably ambitious 10-gigawatt pipeline. To put that 10 gigawatts into perspective for a second, that is roughly the equivalent power draw of all of New York City. Scaling up by over 100 times requires navigating complex global supply chains, hiring highly specialized engineering talent in a super tight labor market, and deploying billions in capital without a single major logistical hiccup. It is an operational scaling challenge of truly historic proportions. And obviously, a massive scale-up like this exposes them to some very serious bear case risks. Chief among them is their absolute total dependency on Nvidia's supply chain to deliver hundreds of thousands of advanced chips. They currently have about 25,000 active chips, but they are contracted for 194,000 Nvidia Vera Rubin GPUs alone. What happens if there's a manufacturing disruption over at Nvidia? Or what if they hit localized grid interconnection delays, despite their whole microgrid strategy? Furthermore, what if the broader enterprise market just struggles to actually monetize generative AI? Those massive multi-year contracts could suddenly face some very intense renegotiation pressure. To defend against that looming threat of commoditization, they went out and executed a $1.65 billion acquisition of Nscale. They're attempting to sell guaranteed task outcomes rather than just raw GPU hours. Nscale basically builds software that seamlessly manages complex AI workloads across multiple servers. By bringing this capability in-house, Nscale is aggressively moving up the value chain. They don't want to just be a landlord for GPUs. They want developers locked into their proprietary software framework, which increases switching costs and solidifies that sticky, recurring revenue. And as we know, in the public markets, a software multiple always pays better than an infrastructure multiple. And to clearly signal to Wall Street that they are fully ready for this transition, they've been strategically stacking their board with heavy-hitting tech, operations, and policy veterans. Adding names like Sheryl Sandberg, Nick Clegg, and Susan Decker is an incredibly smart move. Make no mistake, this isn't just a niche startup board anymore. This is a roster meticulously designed to look exactly like a top-tier listing prospectus. It projects an image of global governance, sophisticated policy expertise, and the kind of operational maturity required to manage a $25 billion publicly traded entity on day one. Ultimately, what they are trying to do here is separate themselves from other neo-cloud competitors out there, like CoreWeave and Lambda, by pitching sovereign, fully integrated infrastructure rather than just pure-play capacity. While their competitors might focus purely on developer experience or geographic spread, Nscale's model emphasizes owning the entire stack and offering AI sovereignty. That means data processing that rigorously complies with regional regulations like the EU AI Act. In an era of increasing data paranoia, this is a pitch specifically engineered to win those massive blank check government and enterprise contracts. So look, they've got the $51 billion backlog, they've got the hyper-growth revenue trajectory, and they certainly have the institutional backing. But the trillion-dollar question remains. Can they actually build 10 gigawatts of capacity fast enough to turn a $51 billion paper promise into hard cash? As this IPO approaches, the market is going to have to decide. Are we looking at the foundation of the next generational tech giant, or simply the most expensive infrastructure bet of the entire AI boom? Whatever happens, you are definitely going to want to keep a close eye on those S1 filings.